Here's the point. We have been multiplying polynomials since we were back in school, where we can use FOIL or a Punnett square and get the product when we multiply them. What we're leading to here is factoring, which is the inverse operation of that. Rather than me giving you something like this, and we use a FOIL or a Punnett square to multiply it, I give you the answer we get to this, and you go back to this original factor form. Let me show you what I mean. It's easier to explain it that way. I'm going to multiply x squared plus 3 times x plus 5, and I'm going to use a Punnett square because I know that that's what the majority of you prefer. X times x squared gives us x to the third power. X times 3 gives us just 3x. 5x squared is just 5x squared. And then the last box, 5 times 3, is just 15. So our answer here, our final product, is x to the third plus 5x squared plus 3x plus 15. It's challenging to write like this. I'm using my computer mouse for writing, and not the easiest thing I've ever done. But if you can bear with me, it will make sense. So the inverse operation here is that I give you x to the third plus 5x squared plus 3x plus 15, and I ask you to get back to where we started on the last screen. Because these are all pluses and adding is associative, we can group these any way we want. We can put parentheses wherever we want. And what we will generally do is put parentheses around the first and second, and then also parentheses around the third and the fourth terms. So what do x to the third and 5x squared have as a common factor? X squared. So I'm thinking about the distributive property here. X squared times what equals x to the third? It would just be x. Plus x squared times what makes 5x? And it's just 5. So we have x plus 5 in parentheses. Then same thing over here. I got 3x plus 15. What's the common factor there? It's 3. So I'll write the 3 out in front of parentheses. 3 times what makes 3x? Well, just x. Plus 3 times what makes 15? It's 5. So I've got 3 times parentheses x plus 5. Now, the x plus 5 here and the x plus 5 here are the same. They're a common factor. I can pull them out in front. So I have x plus 5. And then what remains when I pull that out in front? X squared plus 3. So then I have x squared plus 3 here. The order is different from on the original screen. Let me go back and show you. We said x squared plus 3, x plus 5 at first, and now we're saying x plus 5, x squared plus 3. It's the same thing with just the two sets of parentheses switched, which is fine because multiplication is commutative. The next thing I'm going to ask you to do is factor trinomials. To factor a trinomial, I say we start with ax squared plus bx plus c. And what that really means is there's a number out in front of x squared, and for short I'm going to call it a. There's a number out in front of the x, and I'm going to call it b. And then there's a plain number at the end, and I'm going to call it c. If there's a minus here, we just treat that number, whatever it is, as a negative. So this is the part that takes some explaining. We need to split the bx term in the middle into 2. We find the two numbers that add up to b and multiply to ac, and then we factor by grouping. So what does that mean? It's much easier to show you than tell you. So I made the directions smaller, and I added one additional line and put them off to the side here. Here's the kind of question I'm going to ask you to factor. X squared plus 7x plus 12. What this means is I'm trying to get you to write it as parentheses x plus something and parentheses x plus something. And what are the two things? So a here is 1 because x squared is the same as 1x squared. B is 7 because 7x, and c is 12 because we have just a plain 12 right up here. So we split the bx term in the middle into 2. We're going to split this 7x into 2 terms. We find two numbers that add up to b and multiply to ac. B is 7, and ac is 1 times 12, so it's just 12. We're looking for two numbers that add up to 7 and multiply to 12. I just think of all the factors of 12. What are the pairs of numbers that you can multiply and get 12 for an answer? 1 and 12, 2 and 6, 3 and 4. there's only one pair of those that if you add them instead gives you 7. 1 times 12 is 12, but 1 plus 12 is 13. It doesn't work. 2 times 6 is 12, but 2 plus 6 is 8. It doesn't work. So 3 times 4 gives us 12. 3 plus 4 gives us 7. 3 and 4 are the two numbers we need. So what I mean is we're going to put 3x and 4x in the middle here instead of 7x. So it's going to be 3x plus 4x. This x squared, I haven't changed it. It stays the same. It's still just there. And then the 12, I haven't done anything with that. It just stays the same. It's still there. So I have now 4 terms, x squared plus 3x plus 4x plus 12. Now I factor by grouping. So I'll put parentheses around the first 2 terms and parentheses around the second 2 terms. So x squared plus 3x, what's their common factor? It is x. And if I think about distributive property, x times what makes x squared? It's x. X times what makes 3x? It's 3. Then plus, what's the common factor of 4x and 12? It's 4. I'll write that 4 out in front. And then 4 times what makes 4x? X. 4 times what makes 12? 3. What I want is in parentheses, there and there to be the same, and they are. So then that's a common factor. I can pull that out in front, x plus 3, and then what's remaining when I factor that out is x plus 4, x plus 4. So my final answer is parentheses x plus 3, x plus 4. If you did 4x plus 3x up here, these numbers might have come out in a little bit different order, and you might have x plus 3, or rather x plus 4, x plus 3, which is the same thing because of the commutative property. But anyway, the point is you're looking for an x plus 3 in parentheses and an x plus 4 in parentheses. Do you notice the shortcut, which works when a is 1? Up here, when you got 3 and 4, your answers in parentheses just had a 3 and a 4. Coincidence? I think not.